Hello everyone, welcome back. So today we are going to be discussing this strange little phenomenon that I found with some of my ingots. Here I have some neodymium magnets. They are more powerful than your regular ferrite magnets that you'll find at the store. These ones, well, you'll probably also find them at the store, just gotta look a little bit harder. But these ones are a little bit more powerful. They tend to stick to iron much better. Now, what I wasn't expecting is that they would also stick to copper. Yes, you're probably wondering this too if you know something or two about copper. Copper tends to act the opposite of iron. It tends to repel magnets. It's because it is diamagnetic. I believe that's the correct term. I don't know. I'm no physicist. Anyway, copper tends to repel magnets, but this is interesting. I notice, take this, slide down a piece of wood, goes down pretty instantly, right? Take the same magnet, slide down the copper, it doesn't want to go anywhere. You'll notice it moved a little bit, but not quite a whole lot. It's at the same angle as all the rest of these, of course, but for some reason it doesn't want to go down as much. You could argue that, the surface is a little bit rough, but is it really that rough? I mean, we got this right here, it's got a nice smooth surface, but it's also not going down nearly as quick as it was on the wood. I mean, look at the wood. I don't have magnetic wood, do I? Oh, there we go. It's a little sticky. So I've noticed that this whole array here acts differently. For instance, you might remember this from my second Mokume Gane melt. This ingot had this weird sort of happening with it. Check this out. It is magnetic. It attracts magnets. It is paramagnet. It is paramagnetic, which means that it attracts magnets just like iron. Not nearly as strong, but it does attract them to the point that they stick. Mostly. Sticks a whole lot better than, say, aluminum. Because as you'll notice, this aluminum slides right off. Without prompting or jiggling or anything like that. Now I've got all of these ingots all at the same level. I'm going to go ahead and slide one down each of these. Going to go ahead and start with the wood. Slides down pretty instantly. Do that. Nothing. This goes down a little bit slower. This goes down at a snail's pace. Oh, maybe I'm giving too much credit to snails. I don't know. And this one's got sticky bits. Something interesting about that sticky ingot is that this is my, what I like to call, Stibnic bronze. Bronze with antimony in it. Otherwise known as its Latin name, stibnum. I don't know, something like that. Its chemical symbol is SB. It's named after its Latin name, which is also related to the name of stibnite, which is where we find antimony. Antimony, antimony. I call it antimony because I'm Antimothy. Anyway, just figured I'd show you all that weird thing. The explanation that I've heard about this is that with each of these are all conductive, which means that if you pass an electrical current through it, it'll probably get to the other side. Wood is a lot more resistant. It doesn't tend to conduct electricity that well. So when a magnet like this, the stronger the magnet, the greater the effect, when a magnet like this travels down one of these things, it induces current, which I'm no electronics expert or anything, but I know that that does something to magnets. The currents, the positive and negative, tend to interact a little bit, and it actually slows it down because of the same stuff that attracts magnets to each other, also the same forces that repels magnets from each other. Given their orientation, it makes it want to slide down slower. So I found that really interesting. It was some sort of magnetic eddy current thing. I don't really get it. As I said, I'm not an electrician or anything, but I thought this was really cool. I mean, it just adds a whole new layer of interesting to copper, aluminum, and all these other metals that I melt. Iron, let me just show you guys for a minute, just so you can see. Here I will put iron at the same orientation. It sticks sideways even. So iron, not that interesting, it's just sticky. Anyway, I'm rambling on now, so I should probably end my video. So with that, thank you guys for joining me for this video. I hope you all enjoyed it. I will be hopefully melting things in the same chemical group as this at some point soon. This obviously is not pure neodymium. There is neodymium in it, but it's not pure neodymium. So I'm hoping to melt something in its general vicinity pretty soon. For those of you chemists out there, you know what I'm talking about. Anyway, I hope you all enjoyed the video. Thank you for joining me for this one, and I hope you all have a great day.